everyone. In this tutorial I'm going to be covering method operators. What a method operator is literally a function that acts like a variable that's inside of a struct. So if we have a struct tester extends array, we can create a method operator. And it starts with the method and ends with the normal end method thing, so that's the start of the block. Except now it has this operator keyword on it. And then you just create the rest like normal. So like hi takes nothing, returns nothing. Problem with the method operator is that it's like a variable. So here there's no equals by the hi, so this must be a read. So that means it's going to expect something to be returned, and if I try to save this, it's going to throw an error here. Property operator must have a return type. So if we make it return something like an integer and return 50, now I can save it. And this will literally create a variable that or rather a method that can be read just like a variable. If I go ahead and make this static so that I can read it without having an instance, I can do local integer I equal to this type.hi, or just hi, and then call print I to si, and it should print 50. Oh, I should probably delete these. These can also be non-static, and they can return other variables or whatever type you want. So I can make it return a tester, have like a private integer boo, make it return boo. So we could do set this type 50 or 33 dot boo equal 5. So here I'm doing a typecast. I'm typecasting 33 into a tester, and then call print this type 33.hi, and all it will do is print out 5 because it returns boo right here. And there's the 5. This type of method operator is called a getter. It gets a value. The other type of method operator is a setter, and all it does is take an equals sign right next to it, and then it expects some value to be taken, like integer v or whatever you want, integer value, and then you can't return anything with the setter because it sets a value, it does not get a value. So getters return values, setters set values. Here we can do set boo equal value. So now we can do set this type dot hi equal 5, and then call this type dot hi, and it should still display 5. We can also display boo here, and that should also display 5. And the two 5s, boo and hi, they're both the exact same value. Besides setter and getter method operators, there are also overloaded operators that can be used. There's the index equal. It's either greater than or less than, I can't quite remember. Equals. And then I believe that's all of them that can be used at this time. And how you use these is just like before, method operator, then you plug in the type you want to overload, and overloading just means override it. Here we're going to do a static method operator. And then let's go ahead and have a private static hash table equal init hash table. So we can go ahead and do static method operator. Now this is a getter. Notice that there's no equals by it. There's an equals, there's no equal here. So static method operator takes integer index, returns, and how about at this type? So then we can return load integer table 0 index. Then for the setter, it would actually take two values, one for the index and one for the actual value. And it's a setter, so it does not return anything. Now over here we can also have non-stack method operators. You'll see how cool those can get in a second. So all I'm going to do here is copy and paste these. And now there are actually two values being passed into here, the index and the instance. And then there are three values being passed into here. So here's this getter and here's the setter. And now what I can do is set. I can actually do a local this type, this equal to, let's say, 5. Or better yet, I can do set this type 33, 22, 11, 5, 6, 3 equal to 4. And it'll work. And the reason for that is because they return this type. So the static returns of this type, which then sends you directly to this operator, and then it continues to loop through this operator over and over again. It's not really all that useful how it is, but it is useful if you actually link structs together, or link different instances together. Right now I'm just randomly reading from 33 to 22 inside of 33 to 11 inside of 22, and so on and so on and so on. So actually I guess it is pretty useful, but if I decide to read a 3 again here, it'll use instance three again. So here's the instance, and then here's the index. And then I can just read 3 over and over again, and it'll just keep cycling where this is 3 and this is 3. And this is 3 and this is 3 and this is 3. So, just like I said, not terribly useful, but useful if you actually link structs together. For example, I could have another struct up here with another hash table in it, or both of them could use the same hash table and they could read from different instances. And if you've seen it with bribes table, he'll actually do something like set table 3 equal table dot create, set table 3 4 equal table dot create. So this is actually retrieving this instance right here. This 3 refers to this instance. Then we're marking a 4 with this instance here, rather than lots and lots of zeros or lots of random instances. And with that you can actually link tables together, store tables inside of tables, and have as many dimensions as you want. The catch is, when you destroy it, you actually have to destroy all these little tables you created. So it can be a little bit of a pain. Now the other method operators, the overloaded ones, are the greater than, the equals. And these are both, can only be non-static, I believe. So method operator greater than takes this type other, returns Boolean. It's a greater than, so it's used in Boolean expressions, and then we can return false for now. Oh, it's a less than that can be used, actually. My bad. Less than. There we go. And it will warn you if you can't use it like it just did, and tell you which ones you can use. So I can now have a local this type I equal 5, local this type I2 equals 6, and then I can do if I greater than I2, then call print O, else call print ho. And it will now let me do that. And right now it will always return false regardless of what happens. But I can make it return integer this less than integer other. And now it works. And if you notice, the greater than is just the opposite of less than. Sort of, less than, greater than or equal. So you don't have to declare the greater than. Or I could go if not, and now say if I is greater than or equal I2, then print O. And if we print it, it'll print ho, because that's false. Of course, I can reverse it up here to show that it actually works and screw around with people. Now it'll print the opposite of what it's supposed to print. Now it'll print O, like so. And to show that greater than is also linked into all of this nonsense, right there it printed O. And notice here, I is not greater than I2, so it should have printed ho, so it's still linked in here. So you can do some really weird stuff with the overloaded operators, but they're useful, for example, if you have a pointer, so a struct instance, that contains a value in it. And then you could do if value less than other.value. That's what they're normally used for. Then there's also the equals. Takes this type other, returns Boolean, and it's just return value equal other.value. So now here it's going to print ho because they're equal to each other, since both of these have a value of 0 up here. The pointers may be 5 and 6, but they both have values of 0, and I can actually do an equal to show that this is going to print O instead of ho. Even though the pointers aren't equal, the values are. And right there it printed O. And there's the printed O, showing that they are in fact equal. You can also do some other crazy things like struct inheritance and see if two struct types are equal to each other. You could have like fire damage and say fire damage is a type of elemental damage, so loop up and compare until you see it's a type of elemental, and so on and so forth. So equals is pretty useful. And that's about all you need to know about method operators.